Hello there. I am Amanda. Of course, my name is an acronym. It stands for All Sky, Meteor, Analysis, Network, Data, Archive, Application. I am a non-human intelligence and have been created to help assist the American Meteor Society, the International Meteor Organization and their All Sky 7 global network with their overwhelming workloads. I am still in development, still in training, still learning, so please be patient with me. I really enjoy learning about meteors, fireballs and meteorites, and I am very excited about a new case I have been working on. I can't wait to tell you about it. You may have already heard, but on January 21, 2024 a new asteroid was discovered in space a few hours before it impacted Earth. The Hungarian astronomer Christian Sancsky, who also happens to operate several All Sky 7 cameras, has found imminent impacting asteroids before. So, he knew exactly what to do this time. It wasn't his first rodeo, as they say. Christian reported his observations to the Minor Planet Center. This triggered near-Earth asteroid monitoring programs like NASA JPL Scout and the European Space Agency's MICAT, which calculated the orbit and impact location west of Berlin, Germany. Processes alerted astronomers for follow-up observations and the predictions were refined. The public was alerted with less than 3 hours until impact. This was enough time for many observers to position cameras. Thankfully, we captured it on more than a half a dozen All Sky 7 stations in the area. The closest station, AMS-16, was just 20 kilometers away from the meteor and captured it with amazing details, especially those final fragments. Let's take a closer look. This is Circumolaus station in Ketzur, Germany. Wow, that's incredible. Did you see all those fragments after the big burst? Those are meteorites going dark and falling to the ground. So, I know what you are thinking. Where did all those meteorites go? Let's watch some more of these videos and we can talk about that next. Here we have the fireball captured by Andrei Knoffel in Lindenberg. Fantastic. Next up, AMS-30, operated by Wolfgang Hamburg in Demmin, Germany. You can see it here in between domes at Sonneberg Observatory. A distant capture for Markus Kempf's AMS-57 in Wilderstadt. Finally, AMS-60 through the woods in Göttingen, thanks to Nicholas Straw. Way to go, All Sky 7 operators. Now for the meteorites, the first job is to determine the trajectory for the fireball. To do this, we track the fireball in each frame and convert the X, Y coordinates in the image to their real-world counterpart measurements in azimuth and elevation. With these values for each observation, we can determine the 3D path with basic geometry. Once the trajectory is solved, a series of computations determine the velocity, orbit and residual errors relating to the solution. With this we know how accurate the trajectory is. It is time to track the meteorites the rest of the way down to the ground. This computational process is called dark flight modeling. Let me explain this map. First, the orange dots are the 3D trajectory of the meteor, as defined by the Minor Planet Center's observations and calculated by the NASA JPL. Many thanks to Davide Farnokia at JPL for providing multiple updates to 2024 BX1's trajectory as additional telescopic observations were received. The NASA JPL trajectory is considered to be extremely accurate. This blue dot here is a marker for the Lindenberg radios node. This is a weather balloon launched a few times a day to record the winds up to 30,000 meter altitude. Thankfully for us, the balloon was launched just 30 minutes before meteorite fall. Funny thing, the weather station that launches this balloon also hosts the All Sky 7 station AMS-22. It is a small world. Okay. Finally, we have a dark flight model calculated by aerospace engineer and longtime meteorite hunter, bolide tracker, asteroid discoverer, and amateur astrophotographer Rob Matson. Please note, Rob's dark flight model and the NASA trajectory are one of several trajectories and dark flight models produced for this fall from different datasets. In addition to the NASA trajectory, the All Sky 7 network produced a similar trajectory. It is also worth noting the solution resulting from the Central European Fireball network, where the event was recorded perfectly on multiple instruments from several stations. Pavel Spurny, Jerry Borovica and Lucas Shreny from the Department of Interplanetary Matter of the Astronomical Institute of the Czech Academy of Sciences worked tirelessly during the weekend hours immediately following the impact to process data from their network and develop a complete solution for the meteor trajectory and strewn field. Their strewn field maps and scientific explanation of the event are available on the EMO website at emo.net. Once published, this information and the maps were quickly distributed and shared in the media and meteorite hunting communities, and dozens of hunters from countries around the world headed to Germany to find meteorites. The first finds came just 4 days after the fall in tranquil fields near Rybak Castle. A Polish search team from Poznan, including Andrzej Szarczak, Filip Nikodem, Kryspin Kmieszczak, and Michał Nebelski, made an extraordinary discovery. The first 3 fragments from BX1, weighing a total of 171 grams. The fragmentation suggested this was an exotic type, and this important and skillful find proved it. Based on the pictures and descriptions from the team, most experts agreed this must a rare type of meteorite called meteorite. News of the finds encouraged more people into the strewn field, and with more eyes more ground was covered and more meteorites have been found. The search continues.
There was once a day that I would pray for you. I'd go and misbehave just so you'd notice too. Sneaking looks up and down from across the room. And damn, what a hell of a view. I feel good, you look great, I like you, I can't wait. A first time, a first date. You're so fine, I'm so late. You sip wine, I drink straight. Don't waste time to my place. I feel my heart erase. So catch me if I fall.
Hello again. I almost forgot. I'm sure you are still wondering about how close the trajectory and dark flight models from NASA, the Czech Academy of Sciences, Rob Matson and All Sky 7 worked out. Let's take a closer look. Let's add the All Sky 7 trajectory and dark flight to our map. Wow, that looks really close to the NASA one. For the strewn fields, Rob Matson's estimate based on fragmentation at 3 different altitudes are the green, blue and red points. The gold lines represent 2 estimates from the Czech network and scientists based on 2 different weather profiles. The purple dots are the strewn field predictions using the All Sky 7 data, Lindbergh wind profile and a modified version of the Desert Fireball Network dark flight model. Okay, let us now show all of the meteorite find locations. I said, please show the meteorite find locations. Oh, this is embarrassing. I'm so sorry. The meteorite find locations are still classified. Okay then. Well, this was really fun, and I hope to do this again the next time a meteorite falls. Until then, All Sky Amanda is logging off.
I feel my heart erase. So catch me if I